Hi everyone. In this video, we'll look at what is the difference between a displacement distance graph and a displacement time graph for wave. So if you look at these two diagrams, the shape looks exactly the same. Okay, from a displacement distance graph, I can measure the wavelength, and displacement time graph, we can measure the period, but that doesn't really tell us like what this graph really represent. So maybe I hope to take this video to talk about this and also look at the one of the class exercise question number 5, which many of you have requested to ask me how do you approach or how do you do that question. Okay, so displacement. Let's start with the displacement distance graph. Okay, the displacement distance graph is basically a snapshot of the entire wave itself, like this. Okay, so let me bring away the axis first. So let's say I took this person was doing some rope exercise. So I took a picture of this and I want to find out how the displacement of the wave varies with the distance, okay, of the start of the vibration. This is a displacement distance graph. So the distance is actually the distance of the every single particle away from the let's say the original position or the origin of the vibration, okay, in this case. So the displacement in this case will be the vertical displacement, and the distance is the horizontal distance for the whole rope. Okay, now, okay, we can look at this also. It's the same. Okay, so basically the displacement distance graph is a snapshot. Okay, so the person is doing the rope waves. Okay, so it's moving. But I took a picture, and then I want to know how the displacement differs along the rope. Okay, so at this point, okay, the displacement is 0 and so on. Okay, maybe a better picture is this. Okay, let's take away the axis first. So okay, so this person is doing tie a rope to a tree and start moving the rope up and down to form a rope wave, and then at this moment I took a picture. So this wave now looks like this. Okay, so at t equals to, I don't know, maybe 10 seconds later I took a picture, and then I want to know how at t equals to 10 seconds, okay, uh, the displacement and the distance differ from each other, and that is a displacement time graph. Okay, so basically I'm just dragging the axis here. Yeah, it's just like that. Okay, that means I'm just looking at how the rope or how the wave look like, okay, as an entire thing at a certain period of time. Okay, that time is fixed, okay, fixed by me. Okay, okay, then what is a displacement time graph? A displacement time graph, we can think of it like this. Okay, so let's say I'm interested in this particle over here, which I put with an X. Okay, I want to know how its vertical displacement varies over time. Then I will get a displacement time graph. Okay, I will show you what I mean in the with using the simulation. Here's what a displacement time graph is. So in a displacement time graph, we are actually looking at how the displacement varies for just one particle. So at t equals to 0, the displacement is 2. So displacement is 2 cm. So basically, at every step, I'm going to plot the graph. Okay, so I can speed up the time a bit. At 0.03, the it is 1.6. Okay, and I just keep going like this. Okay, Alright, the plotting is done. So now I have a displacement time graph for this particle over in my simulation. So I started, its displacement was 2 at the start, and then based on the motion, it starts to move down, right? So for every some seconds later, I will note the distance. Okay, it's not a perfect plot, but you can see the shape. The shape is basically similar to that of a displacement distance graph of a transverse wave. So yeah, so basically, a displacement time graph tells us the motion of one particle over a period of time. So unlike the displacement distance graph, which is actually a snapshot of all the particles at one particular time. Okay, so that's the difference between these two graphs. So with that, let's look at the question in our class exercise.